All right, so my name's Robert Douglas. I thank you all for coming tonight and for having me here. I love coming to Geneva. It's just a beautiful city. I even went shopping today. Do you like my new outfit? So, an interesting thing, I've been coming to Geneva for a few years now for business, and this is the first time that I've actually needed my reading glasses to see my monitor. So this is a new thing. It's, I guess, what happens when you get into your upper 40s. So what are we seeing today? Yes, okay, right. Your checklist for running thousands of websites. So I know a little bit about this topic. I won't say that I know a huge amount, but I know a little bit about this topic because of my involvement previously in a company called Acquia, which dealt with companies that ran thousands of Drupal websites specifically. And now I work for a company called Platform.sh, which deals with companies running thousands of websites on any technology. So who even has 1,000 websites? Raise your hand if you have 1,000 websites, personally or with your company. Okay, the best I got is this from the corner. Okay, so that's a lot of websites. So why did you all come if you don't have 1,000 websites? So the types of companies that we've dealt with most recently who have 1,000 websites tend to be somebody like Johnson & Johnson, who have a worldwide presence. They have many brands. They have legal requirements around their products and localized presences in multiple countries, maybe hundreds of countries per brand. And as a result, they also are forced to work with local web agencies everywhere. So, for example, I'm sure that Johnson & Johnson has some web agency somewhere in Geneva who probably helps them with the localization for the hyper-local aspect of the Swiss market that Geneva represents, because they need to. And as a result of their many, many brands, and then their many, many countries, and then the many, many, many localization requirements, they end up working with over 1,000 web agencies for many thousand websites. And that's a mess, especially when you put the compliance aspect in there. Similar to Johnson & Johnson in many ways, also a consumer brand portfolio company is Nestle, who we work with. They were trying to solve these problems by a nice Kubernetes initiative that they ran for a while and failed for around 2,000 Magento and Drupal websites. And now we're working with them. They've put the Kubernetes on hold. As a result, they've saved themselves that work, and they have the similar thing, brands, countries, multiplied. Another profile that I don't have a slide for is a university. In my experience, a lot of universities have thousands of websites where sometimes a few of them are very high-value websites, like the registration website and some of the websites that students all access. And then there are medium-value websites, say departmental websites, so the website for every college in the university, then departmental websites, and then all of their projects. On and on and on, and we can easily get to many thousands of websites for any given university at scale. So that's another profile. And those are maybe governments, agencies also fit into this, but you see the pattern. All right, my presentation, it's an experiment. This is the first time I've given it in exactly this form, so you can give me feedback on whether it works or not. It's basically going to cover all of these topics: development process, coding standards, deployment, infrastructure, updates and maintenance, data, access and monitoring. And it's going to give you a checklist of concerns along with some solutions in order of worst solution to best solution. Okay, so I've got an example. The first one serves as an example. Development process is the first example. So we've got onboarding and offboarding of developers, developer environments, and stakeholder engagement. Okay, the people who care about the results. How do you engage with them and get them involved? So these are all concerns when you're running thousands of websites. All right, when you're onboarding and offboarding developers, if you make them install runtimes and services themselves or give them root access to production, or you have them download code. I mean, like actually click a link and get a zip tarball of code. Or if they're allowed to develop on all of the sites, and you've got 1,000 of them, you get 1-star rating in your readiness to run 1,000 websites. You see how this is going? I'm going to give you this 2-star solution now. Okay, the 2-star solution is that if you give them access to a shared development server, and I'm guessing there's probably some of that still there, that's not so uncommon, or if you check out code from Subversion, or if they have to be added to the development process of each site manually, you get 2 stars. 3-star solution is you provide Docker images, you provide a dedicated development server for each developer, you give them Jira access for triggering their deployments, so I like go close a ticket that kind of like triggers a deployment. And if you run a Jenkins task to add them to the sites they should be able to develop on, great job. You're basically like most of the agencies that I run into when I go to consult for improving the process. What does a 4-star solution look like? If you add your developers to your GitHub or GitLab organization, or if you have an Active Directory managing that to begin with. If you can clone your production basically to local, including sanitizing the data. If you can develop on each branch individually, so like let's say I want a feature that I'm working on as a developer, Jira ticket feature, and I get a complete new environment just for that development effort, separate from all other developments. So like not the development server that everybody else all hacks on together, but like my own just for that branch, where I have a URL that I can send to stakeholders. And if you control which sites they can develop on by adding them to the right team, 4 stars. And then you get the little GIF. So if you start to doze off in my presentation, that's fine. Just wake up when you get to the GIF, because the GIF is the right way.
The GIF that keeps giving.
It's the GIF that keeps giving. Very good. So developer environments, moving down the itinerary for development. So you don't want to use what's ever on your laptop for development, because it's probably not the same PHP or Java or Python environment that you're going to deploy on. You don't want to share a staging server. These are 1-star smells. They smell very bad. And if you use the same type of environment for all of the sites, you're just running into problems. Skip the 1-star. Let's move on to 2 stars. If I find out that like developers are using Vagrant locally, this is in my 2-star category, okay? How do you turn on the fan on a MacBook from the command line? Vagrant up. If ops team has to manually build cloud environments, 2-star. Okay, 3-star solutions. If someone builds and provides a Docker container for local, hey, you probably do that, right? Like, I'm going to be honest, a lot of people have Docker images, and I like Docker. It's a great solution for a lot of things. But if you have to build it to match the production environment and then you grab it, then you've got 2 different processes managing your Docker container and your production environment. It'd be way better if you just can grab the containers that run production and use those locally. So maybe that's the way it is. Maybe you can also do that with Docker and Kubernetes. There's some like blur between 3 and 4 stars here. Also, if you have to use different Docker containers for each site, like it's really heavy if you have to develop on a lot of sites. So, GIF time, developer environments. Robert's opinion here. If you have a fully automated system that reproduces the cloud environment locally, like as an example, Lando is trying to do. There are some DDev, there are a few others that do this. Good. If you have a copy of the production infrastructure for every testing operation with the exact services configuration and data, 4 stars. Okay, so if I want to test a very specific branch, and I can guarantee that it's the same Nginx configuration, the same MySQL configuration, the same data in MySQL, it's just a separate copy of that environment. Good. And if I can quickly switch locally or in the cloud between distinct environments for each of the 1,000 sites and all of their branches, also good. Okay, 4 stars. Good, stakeholder engagement, 1 star. Show the client on production. Hey, do you like it? Blah. 2 stars, show the client on the shared staging server. Blah. 4 stars, send the client a URL that demonstrates a specific feature on a specific site. That's a great power to have because it reduces the context switch reset for your developer. Imagine as a developer you spend all of this time providing a solution based on a ticket, and you have all of these thoughts on how to do it, why you did it, who said what, all of the concerns, these problems you had to solve, all that context. It's like you get into the zone, right? You know the zone, you're developers. You get into the zone. You finish it up, you send it off. If you get feedback 2 weeks later, you've forgotten everything, you don't know why you did a damn thing, you don't even recognize it as your own code anymore. If you get feedback from the stakeholder later that evening or that afternoon, then you still remember everything. So shortening the feedback cycle is really important. So if you can send a URL to your finished product and just say, click here, look, tell me, do you like it? Yes or no? That shortens everything. Oh, and the GIF, by the way, engagement, right? Coding standards, third-party libraries, code quality and testing. Okay, this is the next big category. Third-party libraries, developers download libraries directly into their code base. Blah. Developers use a build system like Composer and check their artifacts into Git. Okay, what can go wrong with that if I use Maven locally? Okay, then if I have any asterisk directives in my POM XML, then I'm going to download the latest and greatest of whatever from the internet, okay? That means that over time, my build artifact is going to differ from build to build. So checking it into Git is only a way to permanently record what I did on that very day. 4 stars, developers check the POM XML, Composer JSON, or package JSON file into Git. And the system applies a unified build pipeline across the developer projects. So these days, in my opinion, the best practice for build pipelines is not to check in the build artifact into Git, but to check the build file itself into Git. Also the lock files. If you have a composer.lock file, it's totally fair to check that into Git and have the system build that. Then you really have exact control. Code quality, anything goes, the application works. Code gets deployed. We all know that's 1 star. We're going to skip straight to 4 stars here. Okay, the best practice around this looks, I mean, there's no end to what you can do to try and improve your code quality, right? Hire good developers, give them training, having coding standards, have unit testing that can block a deploy, okay? Have code linting that can block a deploy. Have blacklisted libraries and code that can block a deploy. So if you have like a list of vulnerable versions of applications or libraries, if you use one of those, that can block a deploy. Best practice demands that you have hooks in your build pipeline for doing regression testing, integration testing, performance testing, any other user functionality testing that you want to cook up in Selenium or any modern tool. Open-ended question, code quality and testing, and it's not my expertise, so won't dwell there, but the build tool has to support that for 1,000 sites, okay, so it has to be unified. And ideally, at the end of that, you'd have a dashboard that says, okay, like, all of these sites are failing their builds because they just upgraded to something. That would help you identify the fact that maybe that agency in Geneva is now doing a really crappy job with Johnson & Johnson's site, something like that. So, moving on to code deployment. Deployment methodology, speed and frequency of deployment, interruption caused by deployment, deploying to a fleet, which would be 1,000 sites in this case, and rolling back deployments are the topics. If I see SFTP, USB sticks, or overwriting existing code in any format, there's 1 star involved. There's actually a 0-star version of this from my anecdotal experience of meeting people who deploy sites. We, Andrew and I, my colleague, know of an agency in Frankfurt that has to drive over to a bank's main data center with a hard drive and give it to the Fortner, what do you call that in any other language? The doorman, who then goes back and hands it off to the IT team and comes back to say whether the deployment was successful. I think that's like -4 stars. So if you SSH into the server and do git pull, but okay, 3 stars because the tools are really supporting you there. But still, you're not supposed to be able to do stuff like that on a production server. Okay, you're probably going to get the right code if you know how to do git merge, especially, or if you know the -f flag. But still, okay, 2 stars. 4-star solution on this one is you git push to your build system. That triggers a deployment pipeline that has a test environment. Another git merge triggers a deployment to production. Old environment is not updated but replaced. And if not, then you could have a deployment like that guy there, where it bites you in the butt. So, speed and frequency of deployment. We update the site twice a year. I've seen this. In reality, this is not from my imagination. Oh yeah, this stuff. Deployment at the end of each sprint. Okay, good. When I started doing Agile in 2008, that was cool. But that's 12 years ago, and we know from a lot of bigger companies like Facebook that you can deploy continuously. There's even an acronym for it these days, CI/CD. Continuous integration, continuous deployment. That means all the time. We deploy every day, many times, as soon as the feature passes testing, even when the site is under load, even on Black Friday for e-commerce sites. And yeah, this can be reality. Does anybody on this continent recognize that TV show, Lucille Ball? Yeah, okay. I'm dealing with geographical, cultural, and generational differences here. But I actually saw that show in black and white on TV. That's how old I am. That's why I need the glasses. All right. Next topic, interruptions caused by deployment. Post a site offline page when deploying. Okay? Probably still have to do that with some of your sites if you're updating the database, I imagine. If you freeze requests during the critical phase when database schemas are being updated and you have a CDN for static stuff so that during that time customers can do the cacheable stuff, you just can't do transactional stuff, yeah, it's okay, 3 stars. And full disclosure, that's what my company offers as a solution. So I only give that 3 stars because really the holy grail, everybody knows it. Everybody wants it, and sometimes you can actually achieve it. It depends on the nature of your website and how much your data schema has to upgrade, or how many caches you have to clear, or when you deploy new code. And this depends on the underlying web application very much, is that customers never even notice that you deploy, no downtime whatsoever. That's also some of the magic of microservice architectures. I saw a very interesting talk about how to do this with database upgrades that includes feature flags and even achieving this nirvana has some really ugly solutions involved. So if you could do that, great. If not, then 3 stars is already pretty good. Next topic, deploying to a fleet, to 1,000 servers or 1,000 websites. One at a time, obviously 1 star. Sorry, this slide's from a Drupal-specific version of this. We'll skip that. The 4-star version is, so there are 2 concepts here. The very obvious concept is that you've got like a dashboard and you've got a new release of your site, and all 1,000 of the sites depend on this core version, right? Your template, your distribution, whatever. And you want to push it out to all 1,000 sites now that you've done a release. I would challenge you to flip that model in your minds. I think it's a more robust model for sites to poll and find out if there are upgrades for them and pull them in when they do. And you can set different frequencies for that. And you can then, the advantage of that is that you can make the upgrade process autonomous on a per site level, instead of triggering one massive operation that's meant to upgrade all 1,000 sites. You know that by making a new release, the sites will start upgrading themselves on their own individual schedules, which you can control, and you'll get reports back whether that's causing any problems. It's more robust. Right, next topic, rolling back deployments, because not every deployment goes right every time. Am I right or am I wrong? Once we deploy, the old site is gone. Updating a server is a one-way street. 2 stars, there's always the backup. 3 stars, we keep the old deployment around, examples given symlinks or on a separate server, in case we're not happy with the deployment. This is kind of the genesis of blue-green. We use DNS or load balancing to direct traffic. Finally, best deployments. The code base specifies not only the application, but the infrastructure. So when you roll back the code, aka git revert, or you would simply commit a previous git commit hash, the infrastructure and the code are reverted simultaneously to the exact state that they were in before. This implies a coupling of the infrastructure definition as code that lives alongside your application code. And since code and data have to go together to make your website run, then obviously you want to take a snapshot of your data, all of your data in a consistent state before you do the update, so that if it goes wrong, you might experience data loss in your upgrade if you're changing database schemas, or for whatever reason, then you can restore the snapshots. All right, next topic. Lots of subtopics. I'll go quickly. Ease of provisioning, versioning. Are your builds immutable? Can you do rollbacks? Development parity with your local environment plus your cloud environment. Shared or isolated infrastructure and disaster recovery. So in terms of provisioning, if you have to open a ticket for anything, you're dead. No tickets. Okay, you should have the autonomy to self-serve. You should have been given permission to create the things that you're going to be responsible for. If you have to collect specifications and it's not defined in some template catalog, these are fine places to be if you have 1 or 2 websites. But when you have 1,000 websites, that just isn't going to work for your organization. If you have to configure machines or install any software manually, this is not going to scale. And if you have to get and then confirm that you got your access to anything, then bad, all bad. Too much human intervention, you can't scale that. Better, you've got virtual machines and Ansible plus Puppet. Very good for 2008. Much more modern is you launch a Docker image, you can develop on that image, and when it's ready, you push it off to Kubernetes and it scales the hell out of it. I'm fine with that. Probably there are a lot of organizations successfully running 1,000 websites with just that. And I've got nothing against it. However, because I'm extremely biased by the company that I work at, I will tell you what we do, which is we define the infrastructure in the code. It lives alongside the application code. The infrastructure adapts automatically every time you get push to any changes in that infrastructure definition. You can create new projects, aka websites, with a click, and they can be based on templates out of a sanctioned catalog. So for example, a Johnson & Johnson or a Nestle can define a catalog of templates that are acceptable code starting points for all of their websites that have their branding, their governance, their permissions, maybe even some content built in. And the infrastructure should scale automatically as you go through the development process into production, and then as the production receives traffic. Right, next one, versioning. No versioning, we'll skip that one. Versioning, infrastructure obeys a template such as Ansible, Puppet, or Terraform. This is great. Then you put your Puppet files or your Terraform files in Git, and then you've got versioned infrastructure, but it's decoupled from the code. So it's old school in my mind. So therefore, the version of the infrastructure can be deduced from the template, but you can't always guarantee, given which one of these you're running, they have different properties, that the infrastructure hasn't changed any since you deployed it, because in some cases you can actually override those locally, and that's bad, 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 bad. So when you're doing versioning, the best practice in my opinion is that the infrastructure is strongly linked to a specific deployment, and that the infrastructure is created specifically for that deployment. You spin it all up new every time you deploy. You don't reuse anything that you had before. The versioning of the deployment, which is a git hash, a commit hash, is thus the versioning of the infrastructure. So when I deploy my code, if I change the color on a CSS file, then that creates a new git hash that is linked to a new version of your infrastructure. Even if nothing on the infrastructure changed, it gets rebuilt and is new. So always new, 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 new. Development parity between local and cloud. Let's get to the good ones. If you have container images that are prepared using guidelines that approximate parity with production, or are even the same containers that you run in production, Docker, Lambda, Vagrant, those are all going to be pretty good. These days, minor versions of MySQL or Nginx aren't going to make or break most application deployments. Of course, you want 100% one-to-one parity. But if we're really honest, it usually doesn't happen. Raise your hand if you think that you develop every application all the time on exactly the same versions of everything that's going to be running in production.
I do it directly in production.
Leave the room. You owe me tax. Okay, nobody thinks that they've achieved that 100% parity. I develop locally, I'm running something precisely exactly what I'm running in production. No? That makes me feel better, and it proves my point that you can be a little bit relaxed on this point, but not too relaxed. Obviously, the holy grail is that the same build process that builds and deploys to production also builds and deploys your local environment. Okay? At Platform SH, we're slowly approaching that. We're not there. When we've achieved the dream, the grand vision, then basically you'll be running a containerized environment which uses exactly the same build process and containers on your local machine as you do in the cloud. Ask me towards the end of the year if we've gotten there. But we're getting there, step by step by step. I love these cats.
Will your new employer let you?
I don't know. Shared or isolated. So 1 star in this question gets server level access to multiple sites at once. So that means I can SSH into a server that is running multiple sites, and I can see all those sites. Remember the great old days of virtual hosts on shared hosting providers, where you could go in and see all of the other customers' virtual hosts that were there, and you knew that you were on the same server as all of these other sites. You couldn't go in and change anything in most cases, but you could actually see their vhost routes and see what they named them, right? Like you could see precisely how many porn sites were running on your shared server. Great. Bad. 2 stars. Environments are segregated by permissions, but not physically on RAM CPU. Remember jail change what was this solution that you could do? Oh, I forget. Skip it. It was a great solution from the Plesk times where you could like create separate Linux file systems for every customer that you had running, and that you could. It was like almost the idea that led to containerization, but it, yeah, but it only applied to the file system permissions. It didn't apply to processes or network or anything else that containers take care of. Yes. Yeah. Better, 3 stars. Containerization saves the day. Guarantees your limited access to CPU, RAM, network, and other things. Has a virtual Linux file PID tree that makes the container think that it's its own operating system, even though it's only a subset of an operating system. 4 stars. In the best case, you would have dedicated infrastructure for each site. Okay? Even containers have limitations. It's really not an option for some sites because it causes scalability issues. If the sites are too small, then you really can't afford dedicated infrastructure. But this is true of most beautiful things in life. There's a compromise between 2 competing demands, and you have to find the compromise that's right for you and your organization. So at Platform SH, we actually have 2 different architectures. We have a multi-tenant containerized cluster where many customers all share a large number of hosts, and their containers float around and go around and like never bump into each other. And if a host dies, the containers just go, woo, let's go over here. And you know, another host comes in, oh, free space, let's go over there. And it's all free and hippie and all that. And then we have an architecture where a single site will have 3 virtual machines at a minimum for a Paxos compliant consensus algorithm replication of everything. And they can scale vertically on those 3 machines to hundreds and hundreds of CPUs and a terabyte of RAM dedicated. But guess what? Expensive. So there's this balance between multi-tenant containerized, where there are guarantees about some things like minimum guaranteed CPU, but I/O on the disks can still cause a noisy neighbor effect. That's why I chose the GIF with the poor girl being noisy neighbored to death. It's a trade-off. All right, next topic, disaster recovery. Start from scratch, recreate the site. Why not? You had to rebuild it anyway. Okay, best is if you can guarantee an exact copy of the infrastructure in a new location and switch over there if it screws up. Or you can just redeploy from Git. At least you know that you've got the same code as before. And you restore the latest backups from the database, and you've got zipped files of the zipped tarballed files of all of the uploaded files, and you put that all back in place, and that won't take too long, right? If your site's broken beyond repair, why not? 3 stars for that. 4 stars, however, if it really goes wrong, and this GIF kind of triggers a lot of things in me, so if you can't see the GIF, I'll give you a chance to be triggered as well. Sorry. The more I looked at it, though, the more I realized, see, he's triggered too, he has to leave the room. The best is if it fails, the automatic replacement of failed infrastructure is automatic. Automatic replacement is automatic. The best is if data just attaches itself to the new services that automatically came up. So let's say you deployed and for some reason you segfault your database, or you, or the server dies in that moment. Then if the best way to do data recovery is if you can unmount your network storage, which is redundant, and remount it on new infrastructure. Seamlessly. That's not even a new import or a backup restore. That's taking literally the same data and just moving it someplace else to machines that work. Or if a data rollback is needed, it can be done with one API call, restore the latest data, and the data should be integral. There are big issues around put into, stored in several different locations. My favorite example for that is e-commerce. If I have a product catalog and I've got the spring collection of women's shoes, then I've got pictures of those shoes. I've got price catalog information of those shoes. When I create a new shoe, there is like a stock entry and a price and an image of it. The image will then get refactored into multiple mobile versions or stuff. The data will all get indexed into a Solr or an Elasticsearch index, and it's stored in the database plus the original files on the, like there are 4 different data sources here, minimum, right? If I then lose my uploaded files and replace it, I could end up with a different image than the derivatives. If I lose my Solr index or my Elasticsearch index, and then I have to re-index to get, then I won't find things in search. If I lose the database or restore the database from a previous version without re-indexing my Elasticsearch, then I can search for things that are in the index, so I'll find them in search, but when I click through to the search result, I won't actually find a product there because they're out of sync. So that's just an elaborate way of saying all of those things have to be in perfect synchronicity. So when you do your disaster recovery backup, it's really important to know that all of those sources of data have been taken care of and all of them are integral, because you don't want to have to import your database, then re-index Elasticsearch, then get the uploaded files and regenerate all the derivative image sizes. That's going to take a long time. Immutability, this is a big one for me. When you can change things on the server, that's 1 star. Immutability. When Puppet or similar systems can detect changes and revert them, thus providing a guarantee of state, then I don't like that because you can still change things. Like, I don't like that Puppet detects that you've changed things and it goes and clobbers. I don't know if it still works that way. Last time I tried it was 2008. 4 stars is that builds are permanent and can't be changed. I would recommend packing your built code onto a read-only file system so that nobody can change it, ever. Not even you. Like, you go in and try and it just says no. And everything about what you build should be disposable, meaning when it's time to upgrade, for example, your MySQL service or your Elasticsearch service, you should throw the old running service away and replace it with a new one rather than trying to update it. Infrastructure rollback. I just skipped to 4 stars here. I'm like late in the day. I don't want to bore you anymore. So reverting to a previous Git commit should revert the entire infrastructure to that state as well. Okay, so I really want to know, since Git push and Git merge are the deploy methodologies to rule them all, I want to know that when I do a rollback to a different previous Git commit, that my code and my infrastructure are taken account of. That's just a side effect of having your infrastructure definition as part of your code. Updates and maintenance. Only a few topics here. Nearly done. Upstream security. Okay, 1 star. Equifax. Who knows Equifax? Anybody know the Equifax case? It was a case of an American company. They're the ones who collect all of your consumer worthiness data. Like, can I give you a loan? Let me ask Equifax. They know how much money you've earned. They know what loans you've taken. They know your police record. They know your phone conversations. Who knows what they know? They probably have blood samples from when you were born. They're evil. Okay, they know everything about you. They're like the worst of American spying, right? They got hacked because somebody didn't update the Java version. And all of the customer data, including social security card numbers and credit cards, were stolen. Millions of them, like 28 million of them or something horrible. Just like, even more, I don't even remember. It's like 1 out of 7 people in the entire country had data stolen because Equifax forgot to update their Java. Okay, so that's why they get 1 star. 2 stars, security mailing lists. I get a mail saying new security release, and I quickly rush in to go and do an update of that module so that it's once again secure. Because, I mean, who reads all their email all the time anyway, right? 3 stars, code vulnerability monitoring. I've got a couple URLs there. No, it's just 1 URL. It's just really long. But there are these really great and cool services these days where somebody saw a business opportunity around looking at your code base, detecting all of the package versions that you've got in it, and determining whether or not you've got security vulnerabilities. That's great. Okay, I'm totally in favor of that. That's a 3-star solution. Okay? Best upstream security is the updates are automatically pulled and prepared for testing on a regular basis without anybody being notified about it, meaning on a regular basis, if there's anything in Composer update or in the POM XML build process that Maven detects that there's anything new coming in, if it's not, if you hash your built code and it's at all different from the previous code, then it's automatically deployed onto a testing environment, testing's triggered, and you get an alert saying all the new security stuff has been deployed, all testing has passed, shall we merge this? Okay, so it takes you all the way up into the step before merging it directly. And that's actually possible. There's no reason why you can't have that. Finally, auditing the fleet, I think finally. How many sites? It's a Drupal-specific one again, but let's generalize it. So let's say you want to know for your fleet how many of the sites are running a specific version of anything. Okay, it could be the latest version of, update version of 6.2 or the best version of 8.5. And those can coincide because they might both be maintained versions of that software, but you need to know across the fleet who's running all of those, because as the owner of 1,000 sites, you have dictated to all of your 500 or 600 web agencies around the world that they're not allowed to develop using anything that's not supported by the project that you're based on, like Drupal in this case, or Debian project. You've also dictated that under no circumstances are you supposed to use libraries that are not on this list that you give them. Okay? Guess what happens when you make rules like that? They break them, they'll go and break them. They didn't read the list, they needed this feature done. The only way that they know how to do it was with that package, not this package. This package is not compatible in Catalonian, whatever, okay? So you're gonna run into situations where you need to diverge from the rule set that you made. Okay, and you just need to be able to monitor it and know that there is a rule that's been broken, there is a package that's being used that you didn't approve of, but being able to see all of that is there. I think I just gave away points 3, so let's get there. So, auditing. Sorry, that GIF's probably a little gross. If you have access to, for example, the Composer lock, or the POM XML, then you can audit with, and if you know that those have been put onto an immutable read-only file system when they're deployed, then all you need is some tooling around auditing those files, and you'll know what's deployed everywhere, because it's not possible for your developers to get code into the running system without going through the build system, okay? So that's actually a really great side effect of the systems that I've been describing, where you put the POM XML into Git and that triggers a build, etc. That means that you only have to have the tooling to be able to parse and read those and report on those files, whichever it is, whether it's pip or Ruby gems, doesn't matter. There's always a record of what got built. And then you can seriously, precisely audit all of your sites in one go with very little code and tooling to see whether your packages are up to date, whether people are using code that you didn't approve of, and why. Right. So the 4-star solution for updating the fleet are, as I mentioned before, the sites are self-updating up until the point that you have to merge them. Okay, so you do want to, a green or a red button that says, go ahead, merge the site. The tests have passed, but yeah, do it manually. You don't really change much code on the individual sites themselves, maybe only if there's customization like the themes or templates or the look and feel, the front ends. But almost everything else is code that's pushed to the upstreams. So even if you have 1,000 sites, then you're going to have things like your authentication module for whatever system that ties back into your back-end tooling, whatever it is. That component on its own with its own release schedule, and all of your sites will auto-update themselves because they detect a new version of that component. Yeah, and most of the updates should come from upstream sources. So just by committing the POM XML that specifies either an Apache project or your local Maven repository project to get your local components that you develop for your organization on your private GitLab repo, then they'll update themselves. That's the holy grail. Oh my God, there's a whole nother section. Going quickly, because I've mentioned some of these. Backup consistency. You want disk level snapshots. Backup frequency and retention. Obviously, you want to back up as often as possible, but that's easier if you have incremental snapshot technology that only captures the differential change between the disk now and the disk when you backed up last. We achieved that with Ceph. How many of you know Ceph? Yes, the man in the corner raises his hand again. Ceph is really great file network system technology that you can read about, owned by Red Hat, really great stuff. For the accessibility of your backups, then, like I said, it's got to be an API. I've seen the situation where sites go down, sites get lost, sites get destroyed during a deployment or an incident, and people have to figure out where the backups are, if there are backups, who has access to the backups, what format the backups are in, and that's, the situation where people lose their jobs. Now scale that to thousands of sites. Okay, let's just say an entire AWS region goes out. Let's say there's an actual catastrophe, okay? A real earthquake, a real terrorist incident, whatever. The thing that, everybody's planned against, but fortunately has not really happened very often in the history of the cloud. But let's say it does happen. Let's say you lose 300 websites at one time. That's not the moment you want to be asking where your backups are. Just saying. And interestingly, I think I forgot to do return to operations altogether, but that's part of the backup accessibility. In terms of managing your teams, this is kind of obvious. You want central authentication, SSO. You want to have a concept of organizations because if you've got 1,000 sites, it's likely that not only do you have internal organizations like the Swiss team and the German team and the French team, but you've also got your customer organizations like the brands or maisons that you're serving that are the, in Johnson & Johnson, Nestle examples, they're like Pampers versus Tylenol, right? So you want to be able to put a developer on a team and therefore give them access to the website development processes that team is authorized to work on. And so in any given project, there are kind of different roles, that. A project manager needs to be able to see what everybody's doing. A developer needs to be able to commit code and make changes to the application. Somebody needs to enable and facilitate all those people by giving them permissions or like determining what the project settings are. Like how many of you use Jira and how many of you have to talk to your Jira admin to get a nice useful field put onto your Jira tickets, right? Is that frustrating or what? But there's a role, like the person who controls the way that the project's set up. So you need to be able to scale that to those people having those roles on 1,000 sites. Monitoring, I don't know. The cat says it all, right? See everything, see all the time. Uptime monitoring, API monitoring. It goes so far as the most sophisticated customers that we have monitor whether or not API endpoints are responding within plus minus standard deviation of X. like in their response time with any given API call. They're also monitoring complete checkout processes or transactional workflows on the application. And you need to be able to set that up really quickly or you won't be able to monitor 1,000 sites. Finally, we work with several application monitoring tools. There are many more, but I find infinite value in being able to look at a dashboard and see the historical performance of your entire stack. That's something that New Relic and Tideways both offer. Blackfire.io, which started life as a PHP profiler, is now moving into application monitoring as well, with support for Python and Golang, so PHP, Python, and Golang. So still not for the Java.NET people, but pretty interesting already. And finally, the conclusions of my talk, which are, if you run 1,000 websites, to do it well, it's based on the same principles as running one website well. Only you've got to scale every aspect of that, and the impact of ignoring any one of those things multiplies. You can get away with a lot when you're only thinking about one website. When you've got 1,000, you don't even know what all of them are. That means the